This video is the first in a series where we're going to develop techniques of integrating rational functions. So first, what is a rational function? Well, rational function is a quotient of polynomials. So if you've got one polynomial divided by another polynomial, then you have got a rational function. Here is an example: 2x minus 1 divided by x squared, say, plus 2x minus 5. So this is an example of a rational function. Now, in this video in particular, we're going to focus at two cases which are very basic. The first case is the case where the denominator is a monomial. Okay, so if the denominator is a monomial, it means the denominator involves only one term. Like you see, this one is a trinomial. So we're talking about cases like, say, x to the power 4 minus 3x squared plus 5, all divided by x cubed. So suppose we want to find the integral of that. Then the other case we're going to look at in this video is the case where the denominator is linear. So that means the highest power of x is 1. So that's something like 5 over 3x minus 1. So okay, so the case where the denominator is linear is going to have two further subdivision. The first one is when this is a proper, when our rational expression is a proper rational expression. The other case where the rational expression is improper. When the rational expression is proper, the numerator is going to be a constant. If the numerator is also a function of x, then this is called improper. Here is an example. So if we have got 4x over x minus 3, this is improper because both numerator and denominator are of degree 1. We've got x squared over x plus 5. This is also improper. Okay, so well, how do we integrate these things before we go into examples? For this case, we are going to introduce a formula that is going to help us to integrate. For these cases here, for the proper improper situation, we are going to divide first. We're going to divide using either synthetic division or long division. And in fact, even for the case where we've got a monomial, we divide first, but in this case we divide using the distributive property of division, where we divide each of these term by term. Right, so yeah, I'm going to show examples of how this works out. So before we get started, we're just going to list three formulas that we're going to need as we work through these, and then we're going to go through some examples. Okay, so these are the three formulas we are going to use to work through the problems or the examples that follow. The first one is just the formula for integrating powers, which says to integrate a power, you add 1 and divide by the new power, so long as the power is different from -1. The power is -1, and the integral becomes ln. Then an extension of this one for the case where the denominator has got two terms, says that the integral of dx of ax plus b is ln of what we have here, and then we just divide by a. This is just the reverse of the chain rule, because you're going to notice that the derivative of this is a. So whenever we're differentiating, that would mean we multiply by a, but since we're integrating here, we divide by the a. All right, so let's have a go at some of these examples. In this first example, we notice that we have got a one-term denominator. So what we're going to do is just to use the distributive property of division to simplify the expression first. So that means we're going to have, so we've got 2x to the power 5 minus 3x squared minus 4 all divided by x cubed dx. So what we're going to do is we're going to divide term by term. So we've got 2x to the power 5 over x cubed minus 3x squared over x cubed minus 4 over x cubed. So that's the distributive property of division. Then x to the power 5 over x cubed, simply x squared, and then 3 x squared over x cubed is going to be the same as 3x to the power negative 1, and then the last one is the same as 4x to the power negative 3. Then now we can simply use this formula number 1 of integrating powers. Simply add 1 and divide. So in this first case, if we add 1, that is going to be 3. So it's going to be 2/3 x cubed. This one, if we add 1, we get 0. So we notice that this is the case where the power is negative 1. So that one always integrates to give us ln. And then for the last one, if we add 1, we get negative 2, and so we divide by negative 2. So then if we just simplify the last case, our expression is going to look like this. Is going to be plus 2 x to the power minus 2 plus c. So that is how the first one works out. Then for the second one, we have got a linear denominator. So integral of x dx over x plus 2, and this is proper because the numerator is a constant. So that means we're simply going to use this formula here. Main thing is we're going to need to divide by a. A is the coefficient of x. In this case, the coefficient of x is 1. So this is simply going to be ln x plus 2 plus c, because we're dividing by 1. All right, then in c, again, we have a linear denominator, got dx over 1 minus 2x. So this time the coefficient of x is negative 2. So we're going to divide by negative 2. It's going to be negative half ln of 1 minus 2x plus c. The good thing with integration is you can always check your answer. So for instance, for this one, if we differentiate this, we're going to get negative half. Then reciprocal of this, as we would do when differentiating, ln is going to be 1 minus 2x. Then we multiply by the derivative of this, which is negative 2, and then this thing is going to give us 1 over 1 minus 2x. So that tells us that is the correct expression of the integral. All right, so for d, we have dx over, I think, 3 plus 4x, 3x plus 4. So in integral of dx over 3x plus 4. This time a, which is multiplying x, is 3. So we're going to have to divide by 3. So 1/3, then ln of 3x plus 4, and then plus c. For e, so for e we now have a improper rational expression. So for e, so we're going to 4x plus 5 divided by 2x minus 1 dx. Now, so we said in this case we need to divide first. So divide first, and we are going to divide using long division. So if we put 2x minus 1 here, 4x plus 5 there, then we say how many times does 2x go into 4x, and it goes twice. Then we're going to have to say 2 times 2x, which is 4x. We write that one there, and then 2 times -1 is -2. We write that one there, and then we subtract. So 4x minus 4x is 0. 5 minus -2 is 7. So what this thing is telling us is that the rational expression 4x plus 5 divided by 2x minus 1 is equal to 2, which is the quotient here, and then plus 7 over our divisor. Okay, so integrating this is the same as integrating that. So if we call this I, so that means our integral I we can write as the integral of 2 plus 7 over 2x minus 1 dx. And then by the property of integrals, we can do this term by term. So the first one is just going to be the integral of 2 dx, which is this one. And then the second one, if I factor out the 7, is going to be the integral of dx over 2x minus 1. This now can be integrated using our formula number 3 above here, which is this one here. So the main thing is what is the term multiplying x. So integral of 2 dx is just 2x. Then this one is going to be 7 into ln 2x minus 1. And then since 2 is multiplying x, we're going to have to divide by 2 there. And that is going to be the final expression of our integral. Okay, so there's still a few to do. What we're going to do is we are going to bring this video to an end here, and then we're going to continue with F in the next video. Thank you for watching.